Welcome boys. Today we have to start next point of this unit transition series elements. Generally last time we have seen electronic configuration of lanthanoids, its properties, lanthanoid contractions, also oxidation states. And last one more point in that is in lanthanoids, that is the application of lanthanoids. Application of lanthanoids. This is the last point in that lanthanoids. Here, application. Generally, these lanthanoids are used in television tubes. आपण जी टीव्ही बघतोय बघा, त्यामध्ये जे आपले जे कलर चित्र दिसतात, तर ही जी पिक्चर ट्यूब असते त्यामध्ये हे लॅन्थेनाइड्स एलिमेंट त्यामध्ये वापरलेले आहे. जनरली हियर in this here the lanthanides are generally used in television tubes. First application, television tube. Second application of these lanthanoids, generally these lanthanoids are here, if you study the lanthanoids, application of lanthanoids, color television tube, this is the first one. Second one, these lanthanides are used inside the surface of television tube, inside the surface of television tube, and in computer monitor. Means first application, that is in color television tube. Then second one, inside the surface of television tube and also in computer monitor for color images. म्हणजे आपण ज्या कलर इमेजेस घेतो त्यामध्ये त्यासाठी त्यामध्ये प्रामुख्याने ह्या टेलिव्हिजन ट्यूब मध्ये असेल किंवा कॉम्प्युटर किंवा मॉनिटर मध्ये असेल, तर ही लॅन्थेनाइड्स आर जनरली युज्ड. देन third application, that is the oxides of, if you take oxides of europium and yttrium, these oxides release the intense red color, release intense red color. These oxides, generally oxides of europium and yttrium, release a intense red color. Then fourth application, that is neodymium, yttrium, aluminium, garnet laser. This is a neodymium, yttrium, aluminium garnet laser. Means here this neodymium is docked in yttrium aluminium garnet laser. Yttrium aluminium garnets, that is the lasers will be prepared by using this neodymium, yttrium and aluminium garnets. This is the one more application. Then fifth application, that will be also here, erbium is docked in generally this erbium is docked in fiber amplifier. One more application, that is erbium will be docked in fiber amplifier. Generally this will be fiber amplifiers. Here this will be one of the application of this lanthanides, that is erbium is docked in fiber amplifier. Then one more application, that is sixth one, that is the lanthanoids. Generally they are used for here hybrid cars. Then superconductors, also in a permanent magnet. Those conducting materials like superconductors are here also prepared by these lanthanides, and also the permanent magnets generally they are prepared. These are the some application of lanthanide, that is color television tube. First one, that is also inside the color, inside the surface of television tube, and computer monitors for color image. Then outside of europium, yttrium release the intense red color. Then neodymium, yttrium, aluminum, garnet lasers also here prepared. In which neodymium is doped in aluminum yttrium laser, yttrium aluminum garnets, and also europium is doped in fiber amplifiers. And one more application, that is the here these lanthanides generally they are used for the use in hybrid cars, also superconductor, and also in permanent magnets. This is about application of lanthanides. Then next point in that chapter, that is here actinoid series. Next one, that is actinoids. First we have to study what is by actinoids. Generally we have seen last time the general electronic configuration of inner transition element, that is n minus 2 f 0 to 14 n minus 1 d 0 to 1 n s2. Last time we have seen if we take n is equal to 6, we obtain this is 4f series. If we take n is equal to 7 and substitute value of here, we obtain that is n minus 2 means 7 minus 2 is 5. Then 0 to 14, here 7 minus 1 6, d 0 to 1, and here n is 7, ns2. This is the general outer electronic configuration of this series, and there the series is also called as 5f series. 5f series, that is the actinoids, their series will be present in the series, that is called as the actinoids, then they are called as 5d series, 5f series elements. What are actinoids? Generally we have to study the definition. These are the generally, this is the second inner transition elements. These are second inner transition elements. Why they are called as actinoids? First here, because the elements present after actinum, they having similar physical and chemical properties, to that of actinum, and that's why they are called as actinoids. These elements generally actinoids, because here they are also called as actinoids because the elements having first elements of that series, that is thorium here 90, and last element that is lorine. So last elements of that series will be lawrencium, that is 103. Last element, that is a 103. This is therefore this such series of elements are also called as actinoids. Then we have to study the position. Here position we know. We have also studied last times, that is the position of both. Generally these elements present in group third. If you study periodic table, group third, and here in 6th period there is a lanthanides, and in 7th period there is a actinoids. Means the position of actinoids, that is in group, that is third, and in period, that is it is 7th period. We know these both series, actinoid series also lanthanoid series, they are placed at the bottom of periodic table. Generally both the series, the 4f series, that is lanthanoids, and 5f series, that is actinoids, both are placed at the bottom of the periodic table. That is position will be in group third, and period will be 7th. This is the position of actinoids. The general electronic configuration, this is outer electronic configuration of actinoids. the general electronic configuration, we have to write this like this as radon Rn 5F 0 to 14 6D 0 to 1 7S2. Because here, why this radon is used here? We know as actinoid series will be starts from, that is from 89 to 1103 Lawrencium. Here the inert gas elements, that is radon having atomic number 86, radon having atomic number 86, it is near or nearer to that series, and that's why here this radon core is used, that is radon core 5F 0 to 14 6D 0 to 1 and 7S2. This is the general electronic configuration. This is general electronic configuration of actinoids. We have seen definition of actinoids, then why they are called as actinoids, and the general electronic configuration of actinoids. Then also some we have to study some points here, that is most of the elements are found. These elements are the most of the elements generally they are not found in the earth or nature, they are not found in the earth. These elements are man-made. These elements are radioactive, they are man-made, and they are prepared in laboratory. They are prepared in laboratory, man-made, prepared in laboratory. Also the half-lives of generally here thorium and uranium. You could have thorium 232, thorium 232, its half-life period will be 1.4 into 10 raised to 10 years. 1.4 into 10 raised to 10 years, and that of uranium 238, that will be equal to 4.5 into 10 raised to 9 years. This is the half-life periods. Generally these elements, the thorium and uranium, these are radioactive and they are found in the rocks on earth generally. These two elements are radioactive. Then next one, generally we have to study also some points in that about that actinoids elements. So they having high melting point and boiling point. Melting point and boiling point. Melting point will be generally greater than 1000 degrees Celsius and boiling point will be greater than 3000 degrees Celsius. This is melting point, or greater than or near about, that will be 1000, and boiling point will be 3000 degrees Celsius. Then next one, these elements generally they are less these elements means actinoids are less reactive. These elements are less reactive than lanthanoids. Also one more point in that these actinoids generally they react with hot water and not that cold. They also form a hydroxides. These elements react with hot water only and not cold, but and also formation of hydroxides with evolution of hydrogen gas, and they are having also oxidation states. Oxidation states will be here +2, +3, +4, +5, +5 and up to 7, +7 like this. These elements form higher oxidation states +2, 3, +4, 6 and +7 like this. This is about the electronic definition, position and some points of that properties or some points in that like this. These are an oxidation states. Then we have to study the electronic configuration of that states. The electronic configuration of actinides we have generally seen here. This is the elements: actinium, thorium, protactinium, uranium, lutetium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium and lawrencium. This is the atomic symbol like this here. This is atomic number of actinium will be 89, thorium 90, protactinium 91, then uranium 92, neptunium 93, plutonium 94, americium 95, curium 96, berkelium 97, californium 98, einsteinium 99, fermium 100, then mendelium x 101, nobelium 102, and lawrencium will be 103. This is the observed electronic configuration. We have seen general electronic configuration of this actinoid series, that is radon core 5F0, then 6D021 and 7S2. If we write this first here, how to fill the electrons here. In radon, there will be radon having atom number 86. Means 86 electron will be completed here. Then remaining 3 electrons. 2 electrons we have to put in s orbitals and 1 from d orbitals. Here in actinum 5f orbital will be empty. Then next one thorium. Thorium having atomic number 90. But here also here in thorium, here the in electronic configuration, thorium having generally f orbitals will be empty in thorium. Then the orbitals will be containing 2 electrons and s2 will be 2. Then here after this, here the electronic configuration, the electrons will be progressively filled in 5f orbitals. Then next one, this is the oxidation states plus the oxidation states. Generally, if we study the first element, that is actinum, then it will form plus 3 oxidation states, means removal of 2 electrons from s orbits, 7s orbits, and 1 from d orbits, that will be removed, and therefore actinum plus 3 ion will be formed, and it having here electronic configuration of actinum plus 3 will be we have also write this radon core 5F0. Then if we take another next element, that is thorium, if we take plus 3 oxidation, that is from here 2 electron from this and 1 electron from either DF or 5F or 5D orbitals. So 6D orbitals will be removed, and then here it will be formed outer electronic configuration of thorium plus 3 ion, that will be 5F1, like this. This is the plus 3 oxidation states, and the atom having ion having outer electronic configuration of that ion generally, means here. Then atomic and ionic radii. Here this is the atomic radii of actinum 203 here in picometer, that will be picometer. Also here ionic radii 126. Why this will be goes on decreasing. Here atomic radii will be 203, but ionic radii will be 126. Means this is outer when these electrons, that is from 7s 2 electron removed and 1 from D, means there the cells these are removed. This means these outer orbits they are removed as the electrons are removed, and therefore size will be goes on decreasing. Atomic size will be 203, but when after losing these electrons, these 2 and 1, then the outer orbits will be removed generally, and that's why here size will be decreased. Atomic size means the distance between nucleus and valence cell. As the valence cell is here, it will be removed generally in there, and that's why size will be goes on decreasing. Similarly, in case of also like this, here will be 180, 162. Here protactinium plus 3 ion will be 118. Like this, atomic size will be generally atomic and ionic radii will be goes on decreasing with atomic number. That is also called as actinoid contraction. One more point, that is here. This is about the electronic configuration of actinoid series. This is the electronic configuration of actinoid series. Generally, these elements here, first we have to study only here electronic configuration, that should be general electronic configuration. For that purpose, we have to write here the inert gas elements generally in the radon, because radon having atomic number 86, it is nearer to that of actinoid series, and that's why it is taken. and then outer shells, that is 5 we have 5, 6d and 7s. These are the outer electronic configuration, and here electron will be filled progressively in 5f orbitals. This is about electronic configuration of actinoids. The next points of that actinoid series will be some properties of actinoids we have to study here. What are the properties of actinoids? Actinoids properties. First properties. The properties are similar to that of lanthanoids. Properties are similar to that of lanthanoids. Properties of actinoids. Generally, properties are similar to that of lanthanoids. First one, that will be color. These are the metals. Generally, these are the white color. Color will be silvery white. Color of these elements will be silvery white. Color will be silvery whites. Second point, that is these actinoids. Generally, we can also call as these elements are highly radioactive, or all elements generally radioactive elements. This means all members, that is they are the radioactive. Then next point, that is as they experience the decrease in the atomic and ionic radii from actinium to lawrencium. These elements we have seen in electronic configuration. Now here atomic and ionic radii will be decreased from actinium to lawrencium. This is as the atomic and ionic radii decreases with increasing atomic number. Here there is a gradual decrease in atomic and ionic size, that is called as actinoid contraction. That is nothing but actinoid contraction. We know the atomic number of actinium will be 89 and that of last element, that is lawrencium, 103, means it will be goes on increasing. But atomic and ionic radii we have seen now, it will be goes on decreasing with increasing atomic number. That is nothing but actinoid contraction. These are the some properties of actinoids. Then also application of actinoids. Applications of actinoids. Generally, we have seen here the thorium oxides with the mixture of thorium oxides with cerium oxide. The mixture of thorium oxide with 1% cerium oxide. If you take the mixture of thorium oxide with 1% cerium oxides, generally it is used as a major source of indoor lighting incandescent. Means here generally this mixture of these both oxides will be used in the household lighting bulb. Means we have to we are used bulb, tube like this. In that, these the oxides of these bulbs, they are filled in that lights material generally. Yeah, means these thorium oxides and cerium oxides, this mixture of this both will be is in the indoor lighting incandescents. Means the bulb which are used, in that bulb both the mixture of these oxides are used. These are the some application. Generally these are the some applications of actinoids. This is the application of actinoids. This is the more important application of actinoids. Then next one, that is the difference between lanthanoids and actinoids. What are the difference between lanthanoids and actinoids? This is the lanthanoids and this is actinoids. Here, first one, and actinoids. Lanthanoids. Generally, we have seen definition. Means the electrons that is called as differentiating electrons, each enters in lanthanoid in 4f orbitals. First difference, that is differentiating electrons will be enters in 4f orbits, and here differentiating electrons will be enters in 5f orbits. Generally, second point that it belongs, this 4f orbital belongs to third group. It belong to third group. Belong to third. That is belong to third group and sixth position and sixth period and sixth period. Period will be 6, and therefore it is a third transition aparts. Third transition series, they constitutes. This is the third transition series and constitutes first inner transition series. First inner transition series means this is belongs to this period will be 6 and group will be third, and it is a first inner transition series. Here second point is that it belongs to, here also period will be 7. Period will be 7. Period will be 7. Groups will be third, and it shows second inner transition series. Second inner transition series means lanthanoid is first inner transition series, and that of actinoid is the second inner transition series. It is present in group third and period 6 under here. Also it is present in group third and period will be 7. Then third points, generally here in lanthanoids, the promethium is a radioactive. Generally promethium will be a radioactive elements, and here uranium or all uranium, thorium, they are all radioactive elements. Promethium is a radioactive, and all these elements of these electrolytes, these elements are radioactive. Then second element, that is except promethium, all elements occurs in nature. All elements occurs in nature. Generally, except promethium, all elements occurs in nature. Then here thorium and uranium. Generally, thorium and uranium occurs in nature, and other elements are prepared in laboratory. Here, except promethium, the lanthanoid elements, they are occurs in nature. But here, thorium and uranium occurs in nature, and other elements that are prepared in laboratory, or they are also called as man-made. Then next one, binding energy. Binding energy is high. Binding energy is high, and binding energy is low. Binding energy means the amount of energy that will. The binding energy means the energy to bind the electrons, outermost electrons. That is called as binding energy. Therefore, here binding energy is high, binding energy of this will be low. Then next point, that is binding energy here is high. Generally, these elements, lanthanoids, are highly reactive, and actinoids, they are less reactive. About if we study the reactivity means generally here they are highly reactive and they are less reactive. Then next points, one more, that is about lanthanoids. They have high tendency. Lanthanoids have less tendency to form complex compounds, and here they have high tendency to form complex They have high tendency to form complex, and lanthanoids having less tendency to form a complex compounds. Some ions of lanthanoids are fairly covalent, or sorry, fairly colored. The ions of next point, that is the ions of lanthanoids are fairly colored. Ions of lanthanoids are fairly colored, and ions of actinoids are deeply colored. Deeply colored means the ions that are formed by lanthanoids, they are fairly colored, but ions formed by actinoids, they are deeply colored. Means we have seen some difference between difference in point of lanthanoids and actinoids. In that we can repeat it again. That is the first point. This, that is, differentiating electrons will be enters in 4f orbits in lanthanoids, and in actinoids it will be enters in 5f orbits. Then second point, that is the we have seen second point, that is it belongs to 6th period. Generally lanthanoids belong to 6th period, and group third generally it represents first blood transition cell, and here it also belongs to period 7, and group third it belongs to second inner transition series, represents second inner transition series. Then next one, third point, except promethium. Generally except promethium, all elements in lanthanoids they are occurs in nature, but here in actinide thorium and uranium occurs in nature, and other are man-made or prepared in laboratory. Then next one, generally we have seen one more point, that is here less tendency to form complex compounds of lanthanoids. Here they have high tendency to form complex compounds, and also ions of lanthanoids they are fairly colored, but ions of actinoids they are they are deeply colored. These are the some important points of lanthanoids. And also one more point, that promethium is only the radioactive, but here all elements are radioactive. These are the some distinguishing points of lanthanoids and actinoids. Then the last point of this chapter, that is post-actinoids. The last points, that will be post-actinoids. Post-actinoids. The last points of this chapter, that is post-actinoids. What is meant by post-actinoids? Nothing but the element having atomic number greater than 92. Those elements which having atomic number greater than 92, they are called as transuranic elements, or transuranic. Transuranic means those having atomic number that will be greater than 92 are called as a transuranic elements. Generally, the elements having atomic number, that is 93 to 103. Generally, the elements which having atomic number greater than 92 means from 93 to 103. These elements they are called as means these elements generally they are called as are included in actinide series, and those form 104 to 118. Generally we have seen the transuranic elements. Transuranic means the element having atomic number greater than 92. They are called as a transuranic. Means the 93, the element present in actinide is from 93 to 103. They are a transuranic elements. They are nothing but transuranic elements. And also the elements, and those form 104 to 118 are called as a post actinides. Means these elements are present after this actinum, and that's why these elements are called as a post actinoids. We can repeat it again as a post actinoids. The elements having atomic number greater than 92, they are called as a transuranic. Which are that? Means 93, atomic number 93 to 103. These elements are nothing but transuranic. And the elements that will be 10, means next to this 104 to 118. This 104 to 118 are called as a post lanthanoids. Means these elements present after transuranic elements, and that's why such elements they are called as a post actinoids. The post actinoids elements are known as transition elements. These are also called as transition elements. These elements are post actinoids because they synthesize in nuclear reaction. They are also called as post actinoids because they are synthesized in nuclear reaction. They are called as post actinoids because they are synthesized in nuclear reactions. This is the post actinoids. We can repeat again this post actinoids. Means the element having atomic number 92 greater than 92, they are called as transuranic elements. Means those having atomic number greater than 92, they are called as a transuranic. That means the 93 to 103, these elements are the transuranic elements. These elements are include actinoid cells, and those form 104 to 118 are called as actinoids, post actinoids. And later to these elements which are present 104 to 118, these elements are the post actinoids, and generally these elements are synthesized in nuclear reaction. These are the synthesized in nuclear reaction. These are also called as these elements synthesized in nuclear reaction, and these elements post actinoids, they are also called as transition elements. This is about the post actinoids.